Hi, I'm Josh with Woodland Mills, and I'm here today with our 10th Anniversary Edition HM126 Portable Sawmill. For the 10th anniversary, we added lots of new features to the mill, which I'm going to talk about throughout the video. But what I want to start with is its standard configuration that we see here. And in standard configuration, we can cut just over 10-foot logs into lumber up to a 26-inch diameter. So the log, 26 inches diameter and 10 foot or just over in length. If we need to add additional track sections, we can. And the track extensions are 6 foot 5 inches long, and you can add as many as you'd like depending on the material you have to cut. We also offer trailer kits to get this mill up off the ground and get it mobile for you. And we're featuring 2 engine options. So we have a 14 horsepower engine option and a 9.5 horsepower engine option to suit your needs as well. Now I want to go through specific details about the mill, and I'm going to start with the track and how we have it set up today on the ground and how we've got it all leveled. So we use an L channel for our track. It's 2.5 inches high by 4 inches wide. It's 1/4 inch thick. And you'll see we have the leveling feet. There's 12 leveling feet, 2 at each bunk, 4 at the center. And what that allows us to do is, based on what we've set it up on, so we have 8x8 timbers here, it gives us 4 inches of adjustment from one end to the other to get the track system level and true. And with a sawmill, it's very important that it's level in both directions. So we have it level left, right, as well as down the length. And these leveling feet will let us get that all set up. You'll see our bunks. We have a nice wide bearing surface on the top. And you'll find this useful when you're turning your material, especially when you've got it cut down to a square edge and you don't want to damage that edge. So this nice wide surface on the top of the bunk helps with that. You'll see we also have the bunks raised up over the tracks here, and that's for loading logs and material. So if you have a tractor with forks, you can come in with your forks and lower it down and leave the log on the bunks and then back out. Or you can use a ramp system that fits over the track and under the bunks to get those logs up onto the track as well. We've got rear log supports. So we ship both a long, which I'm showing here, and short log supports. So the long supports are used when you're first starting a log and it's larger. And then if you have the track system set up high enough, you can keep using the same support all the way down to your last cut. If your track is set up lower to the ground, then the short supports are used so they don't interfere with the ground before you've got down to your last cut height. Next, we'll talk about the clamp system, which rides within the track. And we've got a quick lock clamp system here. You'll see that it rides along this shaft here, and it's got a quick lock feature, which you'll see when we start clamping logs and using the mill. It makes it really quick to clamp that log against the log supports in the back and readjust and clamp as necessary. As we come over to the head, I want to start with the dimensions of the throat opening and the distance between the blade and the saw head here. So on the HM126, we've got a total throat opening of 24 inches. And the distance from the blade up to the mill head is just over 7 inches. So with this, we can make a nice square cut above, 7 inches in height, and 22 inches in width, because we have a slight taper here that comes in a little bit from the guide edge. You'll see this stopper here, and this is designed to interact with a log support as I get down to my last cut, in case I've left it too high. I want to open the guards now, and we'll talk about how the blade rides on the cast iron band wheels and how it's driven by the engine. We have 3 clamps on the guards. We have fully opening guards, so they get out of your way when you're working in here. So inside here you're going to see our band wheels, and we use cast iron band wheels, 19 inches in diameter. They've got 2 sealed bearings pushed into from the rear, and they ride on shafts that pass back through the saw head. Now I can spin this slowly and show you how this goes. So this band wheel, we call the drive band wheel, is driven by a BX series belt, a V belt. We have an idler here with a tensioning arm. So this lets us set the belt tension. It's a simple adjustment. We loosen this bolt and the main shaft there. We could tighten this and then clamp it and retighten, and that sets our belt tension easily. We have a centrifugal clutch here. So the centrifugal clutch is sitting on the engine. At idle, it's sitting idle. It's not spinning. And then as you throttle up that engine, the clutch engages the belt spins the band wheel, and the blade starts and it's ready for cutting. On the follower side, it's the same cast iron band wheel, but we use a urethane belt instead of a V belt. This is more durable, and it gives us a nice long wear. It gives us a nice surface for the blade to ride on as well. Inside of here you're going to see this guard system, and this comes standard with the 14 horsepower configuration of the HM126, and this is an adjustable blade guide. So from that 24 inches I can adjust the throat opening across, and it's going to reduce that opening to 12 inches. So we go from 24 inches down to 12 inches in width. You'll see our guides here. We used hardened steel guide blocks. We have them top and bottom. We have stainless steel set screws that hold those hardened steel blocks in place. And these blocks are set at a clearance to these blades. In case you're to hit something in the wood, these blocks are there to stop the blade from moving too far out of its path and correct it. On the back of the blade, we run a high-speed sealed ball bearing. And again, that's set at a clearance to the back of the blade. And as you push the mill through the material, that bearing is there to respond if you push too hard or you over push on the mill, and the blade can't cut as fast as you're trying to. This guide is the same on the left. It's just hidden here by the guard. You'll see our system here for bringing water and lubricant down to the blade. You'll see the hose here. It runs through the shaft and out onto the blade through this little spigot here. We can set the tension of the locking of the adjustable blade guide with a small set bolt here, and it's automatically locking in place, so I can shift it back and forth and it indexes into the holes provided. When we look at the top here, you're going to see an aluminum tank, and this is where we keep our water and lubricant mix. So we use water with a bit of soap, and that soap breaks up the water so it rides on the blade better. This is a 10-liter aluminum tank, and we use aluminum because it doesn't break down in the sun over time. It's durable, and it won't corrode on the inside. You'll see we have a throttling valve here, so this lets us set the flow rate of the lubricant coming down onto the blade. And we run down, and you'll see a brass valve assembly here. So for the 10th anniversary, we have a new auto lube feature, which when the throttle's depressed, it turns on the water for you. So it becomes completely automatic with the process of the mill. There's nothing to turn on or off with every cut. As you throttle up the engine, it engages the water, and the water flows through the tube and out here on the guide. So you'll see that in the cutting demonstration. You'll see we've also added an indicator to the side of the tank so you can keep an eye on the level inside without having to open up and look down. As I go around the side of the mill, I want to talk about our subframe here, our laser cut plates here in the bottom. So we use these laser cut plates for accuracy. We use them for strength. So we're basically laminating the vertical posts as well as the wheels and axles and spacers to keep everything rigid and firm and to bring all that stiffness up into the saw head. We use, as we come around a little further here, I want to show you the wheels we use on the track. So these have dual race sealed ball bearings pushed inside of them. And we use dual race bearings because they don't have any wiggle compared to a single race. They won't wiggle about them, their shaft. And that gives a nice firm setting on the track and gives us the rigidity we need to carry through that cut. We also have wire sweepers or cleaners for those wheels. So as these wheels ride down the track, we have them designed with a radius inside, so they actually hone into the track over time and make a matched set. And then we use these wire sweepers here to keep the debris out of there and keep them clean so they ride true along that track edge. You'll see we have the stops here at the back, which they interact with as they come to the rear and stop the saw head from coming back any further. As we come up, you're going to see what we call the dashboard on the back of the mill here. And we use 1/4 inch thick steel, and we put a break in it, again, to add rigidity to the saw head. And then you'll see as we continue further, we use 3/8 thick steel, and we laminate those same verticals. And then you'll see as we come across to the top support beam, those 3/8 plates have the beams passed through them and continuously welded all the way around, again for rigidity. You'll see we have loops at the top here, and that's for lifting the saw head if you have the machine to do it, either to get it up on the track or for assembly. On the dashboard here, we have an hour meter mounted. So the hour meter lets us keep track of how long we've been milling, how long the engine's been running, and it lets us keep up with our maintenance because now we know the hours of use. Now I want to talk about our raising and lowering of the saw head. So we use a lead screw assembly because it gives us great accuracy and repeatability. So this lead screw is housed in the back here below our dashboard, and it gives us the ability to raise and lower the saw head with the same distance with every turn. So one turn will always give us the same height adjustment or the same adjustment up and down. So it's easy to keep track of our cuts either by magnetic scale or by number of turns. So that's connected with our stainless steel cables. So we use stainless steel cables to reduce stretch and for corrosion resistance. And they run on a series of pulleys, which again have all sealed bearings pushed into them. So they're nice and smooth to operate and longevity for maintenance. Now I want to talk about our RapidChange blade system. So for our 10th anniversary edition, we separated our blade tension from our blade tracking. And this gives us the ability to have a toolless blade change by simply just taking the tension off the blade. With the guards open, the old blade's going to come off. The new blade goes back on the band wheels. And then we just reapply that tension until our indicator is flush with the collar here. And now we've reapplied the proper blade tension to that blade. What's inside the collar here is a stack of Belleville washers. And those are conical washers. When assembled in a stack, give us a spring-like effect. And that's what gives us the ability to reset that blade tension so accurately and easily. They also act as a shock absorber for the blade. And they take the stress out of the blade when it's being asked to work too hard or if there's foreign material in the log. We went with the Belleville washers over synthetic grommets or rubbers because they're consistent in all temperature ranges. So they give us the same shock absorption and the same blade tension throughout the temperature range that people are going to use their mill. Our RapidChange blade system is housed in our sawhead back beam. The back beam is a critical component to the sawhead because everything is welded or referenced to it, and it has to carry all the loads of the sawhead. So it has to carry the blade tension as well as the work or load being done by the blade. It has to carry the engine weight and the engine's load or torque. Because of that, it needs to be rigid, and for that reason, we've used a continuous rectangular steel tube as our back beam. I mentioned earlier we have two engine options. So we have a 14 horsepower engine option as well as a 9.5 horsepower option. With the 14 horsepower, the adjustable blade guide comes standard. With the 9.5 horsepower option, the adjustable blade guide is optional and can be bolted in the same location. I want to go and show you on the side of the engine. We've included a drain plug extension for changing the oil, and this comes with both engines, but it's going to make maintenance easier or changing the oil easier by bringing that out so you can collect it in a container much easier and it doesn't flow down over your engine mount. The manual tube is where we're going to keep the sawmill manual, so that's going to give you your assembly instructions, your operating instructions, and your maintenance for the sawmill. And the engine manual is going to be in there as well, and that's going to cover the maintenance and operation of the engine. Now I want to go ahead and get a log on the mill, and we'll show you how it works and what we can do with the HM126. So now you see how the HM126 handled that oak log we put on there. Again, it was 8 feet in length, about 19 inches in diameter. The whole process from when I started the engine and started milling to now has been about 30 minutes. And we've milled 85 board feet. Some of it square edged at about 10.5 inches wide. That was all cut at 4.4, so just over an inch thick. And then we took off a few live edge boards as well. Now the live edge boards I can put back on the mill. I can stand them up on the log supports and edge those down and get them down to dimensional lumber before I stack this and start the drying process. We've gone ahead and put the HM126 on our Woodlander trailer. The benefits to having it on a trailer are going to be the mobility, so we can take it to the logs. It's going to be the storage, so now at the end of the day we can put it away. And it's also going to give us a nice elevated work height. So now when we're working around the mill, everything's at a convenient height without having to bend down as much. We're showing the Woodlander in its standard configuration, which is going to let us cut 10-foot logs into lumber. We offer it in an XL version, which is going to extend that, so now we can cut over 16-foot logs into lumber. The Woodlander is a series of components that laminate around the original track system, and we use a 9.5 inch tall, 1/4 inch thick plate, which has a bend in it for rigidity and stiffness that gets bolted to the original track system of the mill. This, in combination with the lower cross beams at all the bunk locations, gives us the rigidity and the stiffness we need when we're milling. Now I want to talk about the various components and do a complete walkthrough of the Woodlander trailer, and we'll start here at the tongue. So we have a 2-inch ball receiver with a linchpin for locking. We have the safety chains and the 4-pin connector for the wiring harness. As we work our way back, we're going to see some front side running lights, and these are LED lights. And then we're going to see our first leveling jack. And the leveling jacks, obviously it's set to level, but they are rotatable and lockable, so for transport they're going to flip up and out of the way. To get the head to stay in place during transport, we have a head lockdown kit which bolts within the laminated plates of the saw head and gives us 4 locking pins, so 1 at each axle of the carriage. And with these in place, in combination with a heavy-duty ratchet strap, we can lock that saw head for transport so it stays where we want it to give us the appropriate tongue weight for the trailer. For the fenders, we've made them removable. So when you're milling, you can take them off so they don't get damaged for log loading. We've got torsional axles. So the torsional axles give us independence from left to right. So when you're transporting off-road, it's much more stable. It doesn't bounce left to right nearly as much as a solid axle would. And this gives us good, keeps the tires on the ground when we're off-road. We've got DOT approved tires on a 12-inch rim, and we have grease packed bearings for longevity. As we go further back, you'll see another leveling jack. So in the standard configuration, we have 2 leveling jack locations on each side. In the XL version, there's going to be 3 jacks per side, and that gets us set up and level quickly with just a standard level across the bunks and using those leveling legs for adjustment. I want to talk now about what else we've done to the carriage head to get it set up to be on the Woodlander trailer. So we've spun the push handle 180 degrees from its upper location for ground mount to its trailer location. We've also moved the throttle from its lower position to its upper position. And this is going to give me a nice user position while I mill. We've also flipped the indicator so we have a better line of sight from sloped down to slope up. As we come around here to the back, you're going to see the side running lights at the rear in red. You're also going to see the license plate holder, the rear tail lights, and we also have an LED light to illuminate that license plate. Although the Woodlander trailer is sold as an off-road trailer package, we do include the various components to aid you in its registration as a home-built trailer in your own jurisdiction. And those components are the 2-inch ball receiver, we've got the safety chains, we have the 4-pin connector attached to the LED light kit with the side running lights, as well as the tail lights and license plate light. We also have the DOT tires. Today we're going to be putting an ash log up on the mill. It's going to be just about 9 feet in length. On the small end it's about 19 inches. On the larger end it's about 21 inches in diameter. Because of its size and weight, we're going to use our tractor today. We could also use our log loading ramp kit. The log loading ramp kit comes with 2 ramps that fit within the bunks. It has a winch post and winch with a synthetic rope that's going to let us go out over the log and back under to help roll that large log up onto the mill. All those components have a storage position within the Woodlander trailer, so when you're going to location, it all comes with you. Now let's go get that log and we'll get it on the mill. So you can see how the HM126 Woodlander handled that ash log. The total elapsed time there from when we started the engine to now was about 30 minutes. We milled about 120 board feet. The square edge boards here are 10 inches wide, about 9 feet long. And then the live edge ones are a little bit wider. And depending on what we want to do with them, we could edge those live edge boards by putting them up against the back log supports and cutting the live edges off. If you are to buy the HM126 as a package with the Woodlander, it's going to ship in 2 crates from one of our international warehouses, whatever's closest to you. We're going to ship it by freight truck, and we offer a tailgate service where available to get it down to the ground for a curbside delivery. I hope you've enjoyed this video of the HM126 Woodlander. This has been Josh with Woodland Mills.